welcome to today's class. Today we will deal with electrochemistry. Electrochemistry. What is electrochemistry? The branch of chemistry which gives quantitative relationships between chemical process and electricity. Chemical process and electricity. What are the important topics in the electrochemistry? One, the first and most important one is electrolysis products, and Faraday's laws. Next, electrical types of electrical conductivity. Types of electrical conductivity. Types of electrical conductivity and Kohlrausch law and its applications. Kohlrausch law and its applications. Next, third important topic is electrode potentials and Nernst equation and applications of electrochemical series. Next, fourth point is types of the cells. And fifth one is corrosion passivity. These are the 5 side headings which we have to concentrate. The last 4 and 5th one is only theoretically we can expect theoretically based questions from the types of the cells and corrosion and passivity. Here in the first 3 topics we can expect theoretical as well as numerical questions from the first 3 topics: electrolysis products and applications of Faraday's laws, types of electrical conductivity and Kohlrausch laws applications, electrode potential, Nernst equations, applications of electrochemical series. In these first three topics we can expect theoretical as well as numerical questions. In the 4th and 5th topics we have to focus on the theoretical questions on the 4th and 5th topics. To start with electrolysis products and Faraday's laws. So to solve numericals based on Faraday's laws, a student is expected to have complete knowledge regarding the nature of the products that are going to be obtained at cathode and the anode. That is highly essential. Now, what is the point? What are the important points to be remembered regarding the electrolysis products? We get electrolysis of the products when more than one ion reach the electrode. What happens during the electrolysis? Cations will undergo reduction at the cathode, anions will undergo reduction at the anode. When more than one ion reach the respective electrode, the ion with less discharge potential will get discharged in preference to the other ion. In case of cations, discharge potential. What is discharge potential? The potential required for the discharging of the ion that reach the electrode. Discharge potential of the cation is directly proportional to the electropositive character. What does it mean? Higher the electropositive character of the cation, greater will be the discharge potential, and it is difficult to be reduced. And In case of anions, discharge potential is directly proportional to the is related to the electronegative character. Higher the electronegative character, higher will be the discharge potential and more difficult for such ions to get discharged. This is the basic point we have to remember. When more than one ion reach the respective electrode, the ion with low discharge potential gets discharged in preference to the other ion. That is the first point to be remembered when we are employing inert electrodes. When we are employing active electrodes, what do you mean by active electrodes? The electrodes which get involved in the redox process that are taking place at the cathode and the anode. When active electrodes are employed, the entire anode metal gets dissolved due to the oxidation and goes into the solution in the form of the ions. These ions on reaching the cathode get reduced and deposited on the cathode. So, in this process there is mass loss at the anode and mass gain at the cathode. So, ions of the electrolyte are not practically involved in the redox process. And what are the other points we have to remember? What are the other points to be remembered? In aqueous solution, 1A group metal cations, 1A group metal cations and 2A group metal cations do not undergo reduction. That is, to be in a broad way, the electrodes with negative SRP values do not undergo reduction in aqueous solution, which will get reduced in instead of the metal cations, 1A group and 2A group metal cations, water will be preferably get reduced, which can be represented as H2 plus 2OH minus. In aqueous solutions, sulfate ions and nitrate ions do not undergo oxidation. Instead, which will undergo oxidation? Water will undergo oxidation. Which can be represented as 4H plus O2. So, in what is the important points to be remembered? In aqueous solutions, 1A group metal cations and 2A group metal cations will not undergo reduction. Instead, water will undergo reduction as follows. And in aqueous solutions, SO4 minus 2 and NO3 minus ions do not undergo oxidation. Instead, water will undergo oxidation. Let us take one example. Suppose if aqueous, when aqueous Na2SO4, is electrolyzed using inert electrodes, how quickly we can identify the products? Na2SO4 on ionization produce Na plus ions and SO4 minus 2 ions. Na plus ions reach the cathode, SO4 minus 2 ions reach the anode, but at cathode Na plus ions do not undergo reduction. SO4 minus 2 do not undergo oxidation. Which will undergo reduction at the cathode? Water will undergo reduction at the cathode. Water will undergo oxidation at the anode. Practically, water will undergo electrolysis when we use this type of the salts are electrolyzed. Practically, water will undergo electrolysis. When water undergoes electrolysis, what will happen? The volume of the solution decreases. As a result, concentration of the electrolyte increases. So, this is the important point. Suppose the aqueous CuSO4 is electrolyzed using the inert electrodes, we get Cu plus 2 and SO4 minus 2. Cu plus 2 undergo reduction and SO4 minus 2 do not undergo oxidation, because when water aqueous H2SO4, CuSO4 solution is subjected to electrolysis. Which ions will reach the cathode? Cu plus 2, H plus, SO4 minus 2 and OH minus reach the anode. Now which will undergo reduction at the cathode? Copper ion. Which will not undergo reduction at the cathode? H plus ion. And OH minus ions will undergo this. What will be the products? Copper and oxygen. And which ions are left over in the solution? H plus ions and SO4 minus 2. What will be the nature of the solution? Acidic. And what will be the pH value? It will be less than 7. So we should have thorough knowledge regarding the reactions that are taking place at the cathode and the anode. Without the knowledge of the reactions that happens at the cathode and the anode, we cannot do anything. We cannot solve the numericals based on Faraday's laws. That is why the first important point is acquiring complete knowledge regarding the nature of the reactions that are taking place at the respective electrodes. After getting ourselves thorough with the electrolysis products, now we can concentrate on the Faraday's laws. What are the Faraday's laws? What is the importance of the Faraday's laws? Faraday's laws gives the quantitative relationship between the electricity and the amount of the products that are going to be formed at the respective electrodes. What is first law? What is the first law? First law of Faraday's law. First law of Faraday is mathematically W is proportional to Q when equivalent weight is constant. When equivalent weight is constant. When equivalent weight is constant. What is the mathematical formula? W is equal to ECT, where E stands for electrochemical equivalent. Mathematically E is equal to E by F. Mathematically E is equal to E by F. W is equal to E by F CT. This is the first law of Faraday. First law of Faraday. Now, when volume is under consideration, the first law of the Faraday can also be expressed as follows. Volume of the gas at STP, volume of the gas at STP is equal to, volume of the gas at STP is equal to, instead of equivalent weight, we will take gram equivalent volume. Gram equivalent volume. Gram equivalent volume by F into C into T. C into T. Now, what is meant by gram equivalent volume? How do you get gram equivalent volume? Gram equivalent volume. Gram equivalent volume. By definition, gram equivalent volume is equal to gram molar volume by N factor. Gram molar volume by N factor. What is meant by N factor? So, by definition, N factor is equal to molecular weight by equivalent weight. So, in our electrolysis problems, we have to remember the gram equivalent volumes of three gases, that is hydrogen, chlorine and oxygen. What are the gram equivalent volumes of hydrogen? Gram equivalent volume for hydrogen is equal to 11.2 liters. For chlorine, 11.2 liters. For oxygen, it will be 5.6 liters. So, this is about the first law. This is about the first law of Faraday. W is proportional to Q when equivalent weight is constant. So, expanding, W is equal to ECT, E is equal to equivalent weight by F, W is equal to E by F CT, and this expression can be expressed in terms of volume as follows. Instead of weight, if volume is considered, the formula takes this form. Next, second law. What is second law? What is the second law? W is proportional to E. W is proportional to E when Q is constant. When Q is constant. So W1 by W2 is equal to E1 by E2, E1 by E2, or W1 by E1 is equal to W2 by E2. So what is the formula? Number of gram equivalents formed at the cathode must be equal to number of gram equivalents formed at the anode. Number of gram equivalents of the product formed at the cathode, total number of gram equivalents formed at the cathode must be equal to total number of the gram equivalents formed at the anode. That is the essence of the Faraday's second law. Now what are the important tips we have to remember regarding the number of gram equivalents? Number of gram equivalents can be calculated. Number of gram equivalents can be calculated as follows. One is weight by equivalent weight, and Q by which can be equated to Q by F, which can be equated to volume of the gas at STP by gram equivalent volume, and number of gram equivalents can also be equated as number of moles into n factor. These are the formulae to be used for the calculation of the number of gram equivalents. What is the essence of the Faraday's second law? For the same quantity of the electricity, number of gram equivalents of the product formed at the cathode must be equal to number of gram equivalents of the product formed at the anode. That is the essence of the Faraday's second law. Now coming to the, let us briefly discuss about the Kohlrausch law and its application. Thereafter we will go for the calculation of the solving the numericals. What is Kohlrausch law? What is the necessity of the Kohlrausch law? Kohlrausch law deals with types of conductivity, and Kohlrausch law is mainly proposed for the calculation of equivalent conductivity and molar conductivity of weak electrolytes at infinite dilution, because graphically equivalent weight for equivalent conductivity and molar conductivity at infinite dilution for weak electrolytes cannot be calculated using graphical method. That is why Kohlrausch has proposed a relation to calculate the equivalent limiting conductivity values of weak electrolytes at infinite dilution. Now what are the types of conductivity? We have specific conductivity, molar conductivity, and equivalent conductivity, and the methods of expressing the molar conductivity and equivalent conductivity. For example, Al2SO4 taken thrice is there. How do you Al2SO4 taken thrice ionizes into Al plus 3, 2Al plus 3 plus 3SO4 minus 2, 3SO4 minus 2. How do you indicate the molar conductivity of Al2SO4 taken thrice? 2 into molar conductivity of aluminum ion plus 3 into molar conductivity of SO4 minus 2 ion. How do you get the lambda equivalent conductivity of aluminum sulfate? Equivalent conductivity of Al plus 3, equivalent conductivity of Al plus 3 plus equivalent conductivity of SO4 minus 2. How do you get equivalent conductivity? Molar conductivity by n factor. For aluminum, what will be the n factor? 3. How do you get for this? Molar conductivity of SO4 minus 2 by 2. So, this is the basic thing. Other thing is factors influencing the conductivity, impact of dilution on the conductivity. Conductivity is mainly influenced by two factors. One, number of the ions. Two, number of the ions. Two, mobility of the ions. No, mobility of the ions. Greater the number of the ions, greater will be the conductivity, greater will be the mobility of the ions, greater will be the conductivity. The impact of dilution on the conductivity will be more predominant for weak electrolytes when compared with the strong electrolytes. That is the important point to be noted regarding the conductivity. Now, coming to the Nernst equation, what is the major application of the Nernst equation for the calculation of the EMF for the cell? For the calculation of the EMF for the cell, how do you get the EMF for the cell? EMF for the cell at experimental conditions is given by the relation E cell. E cell is equal to E naught of the cell, E naught of the cell, E naught of the cell minus 0.059 by N log Q. What do you mean by Q? What do you mean by Q? Nothing but reaction coefficient. What is N? Number of electrons involved. What is E naught of the cell? EMF of the cell at standard conditions, that is E naught of the cathode minus E naught of the anode at standard conditions. So, how quickly we can write the Q depends. So, suppose for galvanic cell, the cell notation is written as Zn plus 2, Cu plus 2, Cu plus 2, Cu. This is the cell notation for the galvanic cell. Using this cell notation, we can get the expression for the reaction coefficient. What is happening at the anode? Zinc is getting oxidized to Zn plus 2. So, this will be on the product side. And what will happen in the anode cathode compartment? Cu plus 2 is getting reduced to Cu. So, this will be on the product side and these two will be on the reactant side. We can neglect zinc and copper because for them active masses is equal to 1. Then what will be the Q value? Zn plus 2 concentration by Cu plus 2 concentration. So, with the knowledge of this cell notation, we can easily write the expression for Q. These are the basic things a student is expected to be thorough with it. So, now we will go to the solving some important numericals. Through numericals, we can discuss the theory also. Come on. During the electrolysis of the cryolite, aluminum and fluorine are formed. And what is the molar ratio? For the same quantity during the electrolysis of a solution, here what is the implied condition there? For the same quantity of the electricity. We are comparing aluminum and fluorine. What will be the number of equivalence ratio? What will be the equivalent ratios? Number equivalence ratios is 1:1. How do you get number of the moles? How to get the number of the moles? Number of equivalents by valency. How do you get the number of moles? Number of equivalents by valency. So, for aluminum, what will be the valency? 3. For fluorine, what will be the valency? 2 here. Because what is the reaction that is happening at the cathode? Al plus 3 electrons giving rise to Al and 2F minus giving rise to F2 plus 2 electrons. How do you get the valency? number of electrons involved for the formation of 1 mole. For the formation of 1 mole of aluminum, how many electrons are involved? 3. That is why valence is taken as 3. For 1 mole of formation of F2, how many electrons are involved? 2 electrons. That is why valence of the fluorine in this electrolysis reaction is taken as 2. Simplifying it, it is 2:3. Simplifying it, 2:3. Option 2. This is the way. How do you get the number of the moles? Number of equivalents by valency. What do you mean by valency? Number of electrons involved during the formation of 1 mole of the elements. For aluminum, how many electrons are involved? 3. For 1 mole of fluorine, how many electrons are involved? 2. That is why valence is taken as 2. Next question. By passing 0.1 farad of electricity through sodium fused sodium chloride, the amount of the chlorine liberated is. Now what is the important point to be remembered? 1 farad of electricity is equivalent to 6.023 into 10 to the power 23 electrons can liberate 1 gram equivalent weight of an element. 1 gram equivalent weight of an element or 1 gram equivalent weight of the compound, as the case may be. Now here how much of the current is passed? 1 farad is equivalent to 1 gram equivalent weight of the chlorine, which is equal to 35.5. 0.1 farad can liberate 0.1 gram equivalent weight, that is equal to 3.55 grams. So option 3 is the answer. Next question. The number of electrons involved in the electrodeposition of 63.5 grams of copper from a solution of copper sulfate. What is the number of gram equivalents involved? Number of gram equivalents of copper deposited. Number of gram equivalents of copper deposited is equal to weight by equivalent weight. 63.5 by 31.75 is equal to 2. For 2 gram equivalents, 2 moles of electrons are needed. For 2 gram equivalents, 2 farads of electricity, that means 2 moles of electrons. For the deposition of 2 gram equivalents, how many farads are required? 2 farad. 1 farad is equivalent to how many electrons? 1 mole of electrons. 2 farads are equivalent to 2 moles of electrons. Option 3 is the answer. This is by definition. The electrochemical equivalent weight of the metal is X. What is the equivalent weight of the metal? Equivalent weight of the metal is equal to equivalent weight of the small e is equal to capital E by F. Capital E by F. Capital E is equal to electrochemical equivalent into F. What is electrochemical equivalent is given as X, and it should be multiplied with 96,500. So option 2 is the answer. Next question. So here also same thing is given, same problem. The electrochemical equivalent is given. What is this equivalent weight? Simply multiply the electrochemical equivalent with 1 farad. So option will be 1. Option will be 1. Next, an electrolytic cell is constructed for preparing hydrogen for the average current of 1 ampere in the circuit. What is the time required for producing 112 ml of the hydrogen at STP? What is the normal formula for the first law of Faraday? W is equal to E by F CT. W is equal to E by F CT. when volume is given, volume at STP is equal to gram equivalent volume by F into C into T. What is the gram equivalent volume of the hydrogen? It is 11.2 liters in terms of ml, 11,200 cc. What is the gram equivalent volume of the hydrogen? How do you get gram equivalent volume of the hydrogen? Gram molar volume by its n factor. For n factor of hydrogen is 2. So, gram equivalent volume is 11,200 by 96,500 into C. What is C value? 1 into T. So, T is equal to 965 seconds. T is equal to 965 seconds. Next. When electricity is passed through the number of Faradays, so that must be, here what is the question? C into T is equal to Q is equal to how much? Is equal to how much? That is the question. So, this formula can be rewritten as W is equal to E by F CT, can be rewritten as W by E. What do you mean by W by E? Number of equivalents is equal to Q by F. Q by F. This formula on simplification becomes this. What is the weight? 13.5. What is the equivalent weight of the aluminum? 9. Q we are supposed to calculate. So, Q is equal to 1.5 Faraday. The same expression can be simplified as this. So, what is the Q value? 1.5 Faraday. Option 3 is the answer. Next question. The charge required for the oxidation of 1 mole of these things. So, charge required in Faradays. Charge required in Faradays is equal to number of moles multiplied by n factor, because charge required in Faradays is equal to number of gram equivalents electrolyzed, which is equal to number of moles multiplied by n factor. So, what is the n factor here? This is an oxidation reduction process. N factor is equal to change in oxidation number. Here n factor is equal to change in oxidation number. How do you get change in oxidation number? Difference in the oxidation number multiplied by atomicity of the element on reactant side. So, for this model problems, this is the basic concept. Now, what is how to calculate the change in the oxidation number of on this side? What is the oxidation number? Plus 8 by 3. On this side, what is the oxidation number? MnO4 minus 2. Here plus 6. What is the change in oxidation number? 6 minus 8 by 3 into what is the atomicity of the manganese on the reactant side? 3. So, it is 10. Now, What is the charge required in Faradays? What is the charge required in Faradays? 1 into 10. 10 Faradays. 10 Faradays. Option 1 is the answer. Next question. Time required to deposit 1 millimole of aluminum metal by the passage of 9.65 amperes through aqueous solution of the aluminum ions. Here same W is equal to, when one substance is under consideration, we have to use the expression of Faraday's laws. When two elements are under consideration, we have to use the expression for Faraday's second law. W is equal to E by F Ct. E by F Ct. What is W? 1 millimole. What is the weight of 1 millimole? 27 into 10 to the power minus 3 grams. What is the equivalent weight? 96,500. And what is C? What is C? 9.65. 9.65 into T. So solving, T will be equal to 30 seconds. This will be 30 seconds. 9.65. 9.65. This is 1000. Option 1 is the answer. Next question. Here two electrolytic cells are considered. What is the point ratio of masses of the iron deposited at the cathode in two cells will be, according to the Faraday's second law, W is proportional to E. So W of weight of iron in the first cell by weight of iron deposited in the second cell is equal to equivalent weight of iron in the first cell by equivalent weight of the iron in the second cell. This is direct application of the Faraday's second law. Now let us come to the what is the content in the first cell? Ferrous sulfate. In the first cell, what is the equivalent weight of the iron? 56 by 2. In the second cell, what is the equivalent weight of the iron? 56 by 3. So the ratio will be 3 by 2. 3 by 2. So 3 is to 2. Option 4 is the answer. Next question. When an electric current is passed, the current passed in 965 seconds. So this is also simple. What is the volume is given? So what will be the expression? Volume is equal to gram equivalent volume by F into C into T. What is V? 112 ml. 112 11,200 by 96,500. 96,500. What is C? We have to calculate. What is the time? 965. So C is equal to 1 ampere. C is equal to 1 ampere. Next, move on to the next. Here, this is related to the Kohlrausch law. In Kohlrausch law, what is the one important relation? Degree of dissociation. Degree of dissociation. Alpha is equal to conductivity of this solution. Conductivity of this solution at a given concentration. At a given concentration by conductivity at infinite dilution. Conductivity at infinite dilution. At infinite dilution. This is the one important formula to be remembered in the Kohlrausch law applications. Alpha is equal to conductivity of the solution at a given concentration. At a given concentration by conductivity of the same solution at a infinite dilution. This will give us the alpha value. Now what is the question? Dissociation constant of the acetic acid. Alpha is equal to root Ka by C. Alpha is equal to root Ka by C. Ka is equal to alpha square C. Alpha square C. Now let us try to calculate the alpha value. How to calculate the alpha value? Conductivity at a given concentration 5 into 10 to the power minus 5, 5 into 10 to the power minus 5 by 390.5. This is the alpha value. How do you get Ka value? Alpha square into C. What is C value? Where C is equal to, what is the C value? 0.001. So find the alpha value from this expression and substitute the alpha value in this expression to get the Ka value. Option 3 will be the answer. Which of the following solution has NaCl has the higher specific conductance? So what is by definition, what is specific conductance? Conductivity due to conductivity. What is by definition, what is meant by specific conductance? Conductivity due to the number of ions present in 1 cc of the solution. 1 cc of the solution. So naturally in the given set of condition, higher the concentration, higher the number of the ions in 1 cc of the solution. So which solution will have greater number of the ions in 1 cc of the solution? 1 normal. So option is the 4. What is specific conductivity? Conductivity due to the ions, number of ions present in 1 cc. Among the given set of the solution, 1 normal solution will have the higher number of ions per cc. Therefore 1 normal solution will have the higher specific conductivity. Next question. Molar conductivity is given, molarity is given, its specific conductivity. What is the expression for molar conductivity? Lambda m is equal to 1000 into K by molarity in Celsius units. Now what is the question? We have to find the specific conductivity. Specific conductivity is equal to molar conductivity into molarity by 1000. What is specific conductivity? Molar lambda 1.26 into 10 square. What is this molarity? 10 to the power minus 2 by 1000. So answer will be 1.26 into 10 to the power minus 3, option 2. But okay, next question. Before going to the next question, molar conductivity in Celsius units will be, in MK system will be K by 1000 into molarity in MK system. In Celsius units, molar conductivity will be 1000 into K by M. In MK system, molar conductivity will be equal to K by 1000 into M. Next, the values of equivalent conductivity at infinite dilution. This is the direct application of the Kohlrausch law. What is given for us? Lambda equivalent of NH4Cl and lambda equivalent of NaOH and lambda equivalent of NaCl were given. So for simplicity sake, for understanding, let it be X, let it be Y, let it be Z. And what is the question? Lambda equivalent of at infinity values, equivalent rate of NH4OH is equal to how much? Here by definition, lambda equivalent of NH4OH is equal to lambda equivalent of NH4 plus lambda equivalent of OH minus. This is by Kohlrausch law statement. From the Kohlrausch law statement, how to get this value? This value? Where is NH4 plus in the first, and where is OH in NaOH? So it will be X plus Y minus Z. It will be X plus Y minus Z. What is the X value? 149.74. What is Y value? What is X value? 149.74. What is Y value? 248.1. What is Z value? 126.4. So by making proper substitutions, we will get the answer as 271.44. Because what is lambda? This thing, NH4 plus Cl minus, equivalent conductivity of NH4 plus Cl minus, equivalent conductivity of Na plus and OH minus, equivalent conductivity of Na plus Cl minus, right? Next. So molar conductivity of a bivalent cation and a bivalent anion. Bivalent cation, bivalent electrolytes are 57 and 73. 57 and 73. Then what will be the molar conductivity? Nothing but 57 plus 73. 57 plus 73. 57 plus 73. Because if we take a solution like BaSO4 or MgSO4, both are molar conductivity. It will be ionizes into Mg plus 2 SO4 minus 2. Then what will be the molar conductivity? Molar conductivity due to Mg plus 2, molar conductivity due to SO4 minus 2. Same, 57 plus 73, it is 130. Option 1 is the answer. Next question. EMF for the cell at 1 atmosphere pressure. So what is the cell notation given? Zn plus 2. Zn plus 2. 1 molar and H plus 1 molar H2. So at standard conditions, what is the EMF for the cell in standard conditions? E naught of the cathode minus E naught of the anode. E naught of the cathode minus E naught of the anode. What is the cathode here? Standard hydrogen electrode. For which the potential will be assumed as 0 volts. Will be taken as 0 volts. Now what is the anode, which is function as the anode? Zn plus 2. For its reduction potential value is given as 0.76. The answer is 0.76 volts. Option 2 is the answer. Next. the potential of the hydrogen electrode is minus 118 MV. What is the H plus ion concentration of the solution? What is the H plus ion concentration of the solution? So for hydrogen electrode, for the hydrogen electrode, reduction potential can be expressed as this: E is equal to E naught plus 0.059 by N log H plus log H plus. Now what is the E value is given as minus 118 millivolts, means 10 to the power of minus 3 volts. What is E naught value? 0. What is E naught value? 0. 0.059 by what is the N value? 1 log H plus So what is the value? This will be 2. This will be equal to 2 because 0.00118 minus 0.118 is equal to log 0.059 by 1 log H plus. This will be equal to 2. So log H plus is equal to minus 2. H plus ion concentration will be equal to 10 to the power of minus 2. Option 1. Considering the following E naught values for Fe plus 3, Fe plus 2 and 0.14, under the standard conditions, the potential of the electrode under standard conditions. So while constructing a galvanic cell, electrode with a high SRP value will function as the electrode with high SRP value will function as the cathode. Electrode with lower SRP value will function as the anode. In the given set, which is functioning as the anode? Tin, because tin is getting oxidized, so tin is functioning as the anode. Iron is functioning as the cathode. At standard conditions, E naught of the cell will be equal to E naught of the cathode minus E naught of the anode. How to decide which is functioning as the cathode, which is functioning as the anode? Because tin is getting oxidized, it will be the anode, and iron is getting reduced, iron will be functioning as the cathode. Now what will be the answer? E naught of the cathode is 0.77 minus of 0.14, it will be equal to 0.91 volts. 0.91 volts. Option 3 is the answer. Next. Now what is the cell notation here? Nickel plus 2, nickel plus 2, 0.01 m, and Cl minus 0.01 m, 0.01 m Cl2. So what will be to calculate the EMF for the cell? What is the expression we have taken? E is equal to E naught of the cell minus 0.059 by N, and log Q. So which will be on the product side? What is the reaction that is taking place at the anode? nickel is getting oxidized to nickel plus 2. This will be on the product side. What is the reaction taking place at the anode? Cl2 will become Cl minus. Cl2 plus 2 electrons will become 2 Cl minus. Nickel is giving rise to nickel plus 2. So, Q will be equal to concentration of nickel plus 2 into Cl minus square. Cl minus square, because nickel and this both will be on the reactant side. Assume no significance. To make it clear, what is the reaction at the anode? What is the reaction at the anode? Nickel is giving rise to nickel plus 2 electrons. What is the reaction at the cathode? What is the reaction at the cathode? Cl2 plus 2 electrons giving rise to Cl minus, 2 Cl minus. What is the net reaction? Net reaction, nickel plus Cl2 gives rise to nickel plus 2 Cl minus. 2 Cl minus. This is the point. So, based on that, what will be the Q value? What will be the Q value? Nickel plus 2 and Cl minus square. Cl minus square. Because nickel is a bivalent, chlorine is a monovalent. So, to equalize the number of the electrons, so this must be multiplied with 2. That is why Q will be taken as nickel plus 2 Cl minus 2. Now, making proper substitutions, E cell will be equal to what is the E naught of the cell? 1.36 minus of minus 0.25. For nickel it will be minus 0.25 minus 0.059 by N. What is N? 2. What is the nickel concentration? What is the nickel concentration? What is the nickel concentration? 0, 10 to the power minus 2. 10 to the power minus 2. What is the Cl minus 7 whole square concentration? 10 to the power minus 4. So, on simplifying it, you will get the answer. What is this value? 1.61. 1.61 into 10 to the power of minus of log 10 to the power minus 6 means minus 6 into 0.059 by 2 by 2 by 2. What is this? If you can take approximately 1.61 plus 0.18, it will be equal to 1.79. 1.79. Option 3 is the answer. Next, aluminum displaces from hydrogen from dilute HCl, whereas silver does not. The EMF of the cell prepared by combining aluminum and aluminum plus 3 and Ag and Ag plus 2 is 2.6 volts. The reduction potential of the silver electrode is 0.8 plus 0.8 volts. What is the reduction potential of the aluminum electrode? This is an application of electrochemical series. In electrochemical series, what is the important point we have to remember? What is the important point to be remember? Electrodes with negative SRP values are considered to be more reactive than hydrogen. They can displace the hydrogen from their solution. As a result, aluminum can displace hydrogen from HCl. Electrodes with positive SRP values cannot displace hydrogen from the solution. That is why in the given context, silver will function as a cathode because it has a positive SRP value. Aluminum will function as the anode because it has a negative SRP value. So, what will be the EMF for the cell? What is the EMF for the cell? EMF for the cell will be equal to E naught of the cell will be equal to E naught of the cathode minus E naught of the anode. E naught of the anode. Now, what is the E naught of the cell? 2.46 volts. 2.46 volts. What is the E naught of the cathode? 0.8 volts. 0.8 volts. What will be the E naught of the anode? That is aluminum. It comes to minus 1.66 volts. Minus 1.66 volts. Thank you. We'll continue tomorrow.